So next thing is, let's talk about the OpenShift. So OpenShift, again, we talk about how can we request allocation using the cold front, and where we can access the web URL for the OpenShift. So once we get the allocation approved for the OpenShift, we can see that information here on the cluster. And if you are part of different projects or allocation, we can see them as a drop-down list. So you can easily switch from one project to another. And for this demo project, what we are trying to do is we're going to see some custom application that can be built on top of it. Simple Node.js app that is a container-based application that can be deployed and run on OpenShift. And also we can see how it is different than the virtual machine-based resource, because in containers, we can easily scale up and down based on the need, rather than setting up a dedicated VMs on the OpenStack side. And also we'll see the GitHub's or CI/CD pipeline that can be integrated with NERC OpenShift, so that it will help developers or researchers to rapidly develop any applications or application rather than focusing on the infrastructure. So for that, we just need to so on the OpenShift side, there are some default developer catalogs available. So this is provided by the default Red Hat. So if you want to use simple Python web server, we can just create and launch it. On the back end, it's going to use this GitHub page where it has all the resources required to deploy this on the OpenShift. Or if we want, we can also upload our own GitHub. So for example, I have this simple Node.js app, which is based on Dockerfile. So in Dockerfile, what we have specified is the base image using Node.js, and all the packages are included in this repo. And then we exposing code 3000 to run. So that's why we need to specify the target code is as a 3000 and then launch it. Right. So here, what it's doing in the background is it's trying to generate the pods that is required based on the containers we specify on the Docker file. And then it deploys it into our OpenShift project namespace. So the one we just deployed using Python has this basic hello world kind of app. And for the simple Node.js app, it's still building. So we can navigate through all the process, like what is happening in the background. All the events can be also tracked and viewed as a PI or the user for this OpenShift. So we can see what is the event happening during the launch. And the benefit of having OpenShift-based workload is it is very easy to scale up or down based on our need. So if we want to scale this container to have multiple pods, now we can just click on this up arrow key, and it will deploy multiple pods for that application to make it more highly available and scalable. And if we don't want that, we can just lower it down to 1. Another benefit is we can also have some threshold setup. So suppose we want to create a new pod whenever the CPU utilization or the memory utilization is up to that threshold, then it will automatically scale up and down based on that configurations. So here, the simple Node.js app is just posting some basic response from the web server, and we can see how can we use a CI/CD pipeline to deploy this kind of application next. So for it, and also releasing all the resources to minimize the cost we can just delete the application. So all the resources underlying that application will also be deleted. Okay. So the next top. So for that, I have that the GitHub repo, which is connected to my local GitHub CI/CD pipeline. So if we look into that GitHub, this is the same GitHub repo we are using, and we have the pipeline files located here. So the pipeline uses different secrets, like what is the OpenShift server, tokens, and what is the namespace of the project that we want to deploy this application on. And once that is triggered using our GitHub action, that will be deployed into our OpenShift cluster here. So for that, all we need to do is configure our OpenShift credentials so that it can run the OC command from our GitHub. And then we also need to specify the GitHub CLI so that it can run the registry commands to connect with our GitHub people. And we can just run this secret set file. So the set secret or set all the secrets needed for this repo to work with the pipeline. So if we look into the pipeline, the secrets are stored in this repo on this file. So you can see those secret values have been updated once we run this set secret command. And now we can just change some of the file in our application, and that will be deployed into the cluster. So for example, instead of using hello from now, I'll just use demo and then commit this change. So whenever we commit any new change on this repo, then it will trigger So whenever we change some code on our application, now it is connected to the CI/CD pipeline, and using the GitHub actions, now it will run all the pipeline that we specify in that pipeline file. So to view that, we can just see on the action tab, we can see all the CI/CD pipeline has been triggered. And they have different stages here. So you can see the build stage, I'm going to build the new image, registry image on using the new Docker file, and it will try to push that into my registry specified in this pipeline. So currently I'm using the so if you look into the pipeline files, we can see what are the steps it involves and which is the registry file registry we are using. So I'm using this Quay-based registry, and this has the simple node app registry located here. So every changes will create a new latest registry tag and update that. Because I already provide the password on my secret, so it can connect to my registry using my username. And also we provide the credential for service server and the token, so it can also deploy that into our OpenShift cluster. So that's how it works. And once that is deployed, we will see it here. Yeah. So once that is completed, you can see all the build stages are complete. And even from here, you can see the URL to navigate to your web application. Yeah. So the change that we recently made in our code is reflected here. So all this pipeline is one-time setup, and next time all the team members or users can just use the same pipeline. So you don't need to configure this pipeline over and over again. So that's the benefit of having OpenShift. So it provides you all the rapid development kind of tools. And then that can be integrated with your work, and that will minimize any administrative task you need to do for any repetitive task, right? And then beside that, we can also integrate other pipelines like testing or even security checks. Those kind of things can be integrated within that pipeline. So this is the most cloud native kind of ways to do it. And benefit of having OpenShift is they also have this like a local registry pipeline we can set up. So instead of using a GitHub and GitHub Actions to deploy our application, we can use the OpenShift inbuilt pipeline. So it will maintain all the repository within this, and we can create a similar kind of pipeline to trigger all those new changes into our applications. So that's another way. So OpenShift has other built-in features that we can use to rapid deployment and development and testing of our applications. Okay, so that's overall for the OpenShift. Is there any questions on this?